So let's see how it'll work if we want to solve some equations that have absolute value signs in them. We'll start with a really simple example. So something like this, the absolute value of x is equal to 5. Now this is essentially saying which values can we take the absolute value of and get 5? Well, there are actually two, right? If we take x equals to 5, well, the absolute value of 5 is definitely equal to 5. But we could also take x equals negative 5, because if we take the absolute value of negative 5, we'll get positive 5 as well. So it turns out that this actually has two separate answers that satisfy the equation. So we're going to take this concept and apply it to absolute value equations that are a little more complicated. So for instance, let's look at x plus 5 is equal to 7. So essentially what we're saying here is that whatever is inside of this absolute value sign, whenever we take its absolute value, it needs to be equal to 7. So there's two things that will work here. If this inside was equal to 7, then that would get us 7 after we took the absolute value. And then if the inside were equal to negative 7, that would also get us back to positive 7 after we take the absolute value. So what we can do is split this up into two cases. So we can say this will be true either when x plus 5 is equal to 7, or it will also be true when x plus 5 is equal to negative 7. This is exactly what we just said. And from here we can just solve these two equations. So I can subtract 5 here, then I can subtract 5 here, and then 7 minus 5 is 2, so I'll get x equals 2. And then negative 7 minus 5 is negative 12. So these should be the two solutions to my equation. And sure enough, if you check these, 2 plus 5 is 7, absolute value is 7, negative 12 plus 5 is negative 7, and that absolute value is also equal to negative 7. Let's try this one. In this case, I don't want to split my equation up until I have it in the form of my absolute value equal to some number. So I want to get rid of this minus 2 before I do any of the splitting up into the two cases. So we'll just do that like you might think. We'll add 2 here and we'll add 2 here. And then I get absolute value of 2x plus 7 is equal to 7. And now from here I can split it up into my two cases. So this will be 2x plus 7 is equal to positive 7, or 2x plus 7 is equal to negative 7. And then we just need to solve these equations. So if we subtract 7 from 7, we'll get 0, so 2x equals 0. And if we subtract negative 7 minus 7, that's negative 14. Dividing by 2 on both sides. 0 divided by 2 is 0, and then negative 14 divided by 2 is negative 7. So our two answers for this are x equals 0 or x equals negative 7. They should both satisfy this absolute value equation. Let's look at this one. If we look at this equation, this should instantly kind of tip you off that maybe something's wrong, at least if you look at it really closely. If we take the absolute value of something, this number has to be a positive number. But if we take a positive number and add it to a positive 6, there's no way we'll ever get down to a 5. We need this to be a negative number for that to work. So we actually know there's not a solution to this equation, but maybe you didn't see that. So let's go maybe the next step you would take and then see how you would realize that there's not a solution. So the next thing I would do is just subtract a negative 6 to get the absolute value by itself on one side. Well, here instantly I see it's much easier to spot the problem. If I take the absolute value of anything, I'll never get a negative 1. So this, in fact, doesn't work. There's no x value that you could put in here so that when you take the absolute value, you'll get a negative value. So I'll actually say that this one has no solutions. Okay, so it's possible that you'll have an absolute value problem that doesn't have a solution, where there's a variable that won't fit in and actually get you a correct equation. Now the last thing we can look at is if we have two absolute value signs. So something like this. I'm still going to kind of work this the same way, but now I'm going to split this up into the cases of 2x plus 7 is equal to positive version of the entire term on the right, or 2x plus 7 is equal to the negative version of everything on the right. So when you put that negative out there, it's negative the entire term. So you have to make sure you put it in parentheses and then distribute the negative out. So from here I can finish this out. I'll subtract a 2x here, and I'll subtract a 2x here, and that'll leave me with 7 equals to 9, which of course is not a true statement. This is a false statement. That's okay. That just means that we don't get a solution from this side of the split. Whenever we have the double absolute value sign, sometimes this will happen, and we won't get a solution from one side or both sides, or you might be fine. You might still get two solutions. So just keep that in mind. If that happens. So we have at most one solution for this if this one works out, which it does. So the first thing I need to do for this side is I need to distribute the negative sign. So that will change this to a negative 2x minus 9. Then I can add 2x to both sides. So I'll end up getting 4x. I can actually go ahead and subtract the 7 too, right? You can do this all in one step. And I'll get 4x is equal to negative 9 minus 7 is negative 16. And then when I divide by 4, I'll get x is equal to negative 4. And that's the only solution that I'll get from this particular equation.